Morning, Mamrita. So in the last class, we have discussed about a concept called algorithm, and we have explained the step-by-step procedure how an algorithm can be written, and also we have seen the characteristics of an algorithm. And today we're going to have a discussion on flowchart. And I was explaining about the importance of writing an algorithm when it comes to writing a program or when you write a solution for a problem. So it's a step-by-step procedure where we try to explain each and every step in steps so that the solution can be achieved. Now coming to flowchart. So flowchart, you can say that it is a design. It's nothing but a design what we're going to write at initially before going for a solution. And this flowchart helps even a person who's not having sufficient knowledge in solution can also understand it each and every step in a diagrammatic way. And when you go back to the history of flowchart was first written and it was designed by John von Neumann in the year 1945. So at the time of Second World War, there was a necessity of understanding the operations. So that's the reason why this von Neumann, who has written this concept called flowchart. Flowcharts uses different symbols. Generally, it makes even a normal, knowledgeable man can easily understand the things with the help of these symbols. So that each symbol represent a different activity, so called as about input. That means when you try to solve a problem, so we have to understand about the input, and then we try to write the information in that, so that is data will be filled, and then it is going to have some operations, and we are supposed to take certain decisions, and we are also supposed to write the output. So likewise, starting from input, we're going to have a data that is going to take reading of the data. The next thing is operations, so called as arithmetic operations, and we're going to have decision box, so that we decide whether it is yes or no. For example, if it is yes, we'll have one certain procedure. If it is no, that will have a different procedure. Likewise, flowcharts are generally written. Now let us just go in depth into the concept called flowchart here. It is considered as a blueprint of a design used for solving a specific problem, so that this blueprint will help them, even a man with such lesser idea about the concept can also understand how this process has happened, so that just following this flowchart they can proceed in case of giving a solution for the problem. So what are the advantages that we got with the help of this flowchart? So it is an excellent way of communicating the logic of a problem. First of all, we have to understand, that whenever you talk about writing a program or solving a problem, we have to understand the logic behind that. Once you identify the logic, once you just interpret the logic, it is very easy to give a solution. So that's the reason why this is the first advantage that we got with the flowchart, and easy and efficient to analyze problem using flowchart. And one more thing, even after writing the solution, right, let us say you are a new reader, you can understand the solution, how it has happened. That means each and every step, so that we can go back, so called as predecessor step and successor step can be understood, and the solution can be easily analyzed. So it's not just only finding the solution, it's also about analyzing the problem, so that it will help us for fixing the knowledge and logic behind that particular program or problem. Now during program development cycle, the flowchart plays the role of blueprint as well, as which makes program development process easier. So this is one advantage. Another advantage is successful development of a program. It needs continuous timely maintenance during the course of its operation. So as you know that when it comes to maintenance, it means whenever let us say you have written a flowchart for a problem, and what happened is the program has been slightly redesigned, let us say a slight changes have made, then you can bring some changes in the flowchart, so that the required flowchart is going to be found for the problem that we need. And it is easy to convert the flowchart, whatever that is there, like information in any programming language code. This is also one thing, that when you go to the solution, especially in the programming languages, this will help us, because that code what you want to prepare, that will be easily understood with this flowchart. So converting the flowchart into the programming language code. You know that whenever you convert this, that means even whenever that is needed, let us say the decoding is possible with having a stronger language code, programming language code. So writing of programming language code depends on the clarity of this flowchart and also the effective method of writing the flowchart. So this is what regarding flowchart. So we have to understand that flowchart is necessary. Flowchart is necessary for what? For understanding the problem solution, for making the problem into step-by-step operational procedure, and having clarity about coding, as well as making this to implement while writing the program. And whenever you try to redesign the things, the redesigning of the things is also possible for the purpose of making certain changes within this particular flow chart. Now let us go for the various symbols that what we are going to use for the purpose of writing this flow chart. Now flowchart is always going to be called as a diagrammatic representation. So it is a diagrammatic representation, and each diagram will have a specific requirement, so called a specific operation or activity, and it is a representation of sequence of steps to solve any sort of problem. So when you talk about these various, first of all we have to understand the various diagrams or symbols that we are going to use. First symbol is oval. So what is this symbol? This we call it as start symbol. So generally you can see this symbol to start any program or any operation. First thing is you have to start with, okay, and so on the end of the flow chart also we're going to put a stop. So what we have to understand about this first symbol is it is start or stop. So starting of the program, so the starting of the program and closing of the program, so that the flow chart will start with this symbol called start symbol, close with this symbol called oval, this oval symbol. Now parallelogram. So we know that parallelogram, so it is for the purpose of using, or you can say putting input and also taking output of the operation. So for example, you see when you take two variables, two values like 2 into 3, 2 is multiplied with 3. So 2 into 3 is equals to what? We know that 2 into 3 is 6. So that value what we have got, that 6, that will be taken as output. At the same time, imagine you can take x, y, let us say x and y, two variables. So the value of x is equals to 2. Let's say a value of x is 2, the value of y is 3. Now x is equals to 2 and y is equals to 3. Now what are that values we are taking? 2 and 3. So this is again input here, x value and y value. After that we got to get xy value, that value what we have got is 6, that is also output now. Now in the same way, the next symbol is rectangle. So rectangle, it is about processing. It is a processing, and it is used for arithmetic operations and data manipulations. So it's a very important symbol. Reason is whatever the calculation you do, that calculation will be done in this rectangle box. For example, as I was telling, 2 into 3, now multiplication, that multiplication will be done in this rectangle symbol. So that multiplication operation is represented with the help of rectangle symbol. Now moving to the next, that is diamond, so called as rhombus. We can also say it is a rhombus symbol or diamond symbol. And you know the difference between a rhombus and a rectangle, square. So rhombus and square looks very similar, but only thing is the diagonals are not equal. That is what major difference between what you call rhombus and square. But when it comes to this rhombus is also known as a decision box. It is known as a decision box, right? So used to represent the operations in which there are 2 or 3 alternatives, true and false. Let us say there is a possibility of exception or rejection, or there is a possibility of taking value A or B. Likewise, for example, when you are comparing two variables, imagine A and B are two variables, imagine, so that A greater than B, if A greater than B is true, then the process is different, let us say, and if A greater than B is false, then we follow some other step. So likewise, when it comes to decision box, this will decide about moving of flowchart. So it will give two alternatives. In case if it is yes, what is the process? In case if it is no, what is the process? Likewise, we're going to have two alternatives or two or more alternatives also possible in certain cases. Now next, moving to the box. So we have to understand these four boxes are very important, and the first box is oval, that is start and stop box we call, and parallelogram, it is called as input output box, and there's a rectangle which is called as processing box, or it is also called as arithmetic operations box. Next, diamond or rhombus box. So diamond or rhombus box tells about decisions, so it will decide about decision, it will decide about which method or which alternative way we should go. And then moving to the next one, that is arrows. So you can see the symbol here, arrows, it is flow line used to indicate the flow of logic by connecting symbols. So one symbol is connected with the other symbol with the help of these arrows. So arrows actually like junctions here what we're going to create, and so that it will give some clarity about our flowchart, and it gives clear appearance about our flowchart. Next, circle, it is like page connector we call, so that whenever there is something called continuation about the flow chart, imagine the number of operations or more, or number of activities are very large, then we're going to have this page connector. So we have to understand these remaining boxes which are after decision box are moreover like extra symbols that we use for the purpose of creating the clarity. And off page connector, so off page connector, you can see this symbol here, and the next is this a predefined process, so called as before getting into the process what we going to put, that information comes under predefined process, like functions used to represent a group of statements performing one processing task. That means whatever the statements we write, before going for the actual process box, that is, that rectangle is process box, so information which we put regarding that operations predefinedly is going to be mentioned with this. And you see one more symbol here, this is preprocessor, that is operations which we do before. Pre means before activities. So two important things here. So here one extra symbol which we use here for the purpose of predefined processes, and here this is called as preprocessor, that means the activities what we use, and ultimately we're going to use the last symbol here is comments. So comments in the sense you can talk about the program relevant information, maybe telling about the merits or demerits of it, or anything which you are that you want to add such additional information to that particular flowchart will be added with the comments. So but anyhow we have to remember these first four are very crucial, because with the four boxes we going to write the flowchart mainly, and the remaining are additional information which we are going to use based on the requirement. Now moving to this here, let us understand few more things here. Assignment symbol, so that we can take these assignment symbols here. So you can see these arrow marks are equals to, for example, when you want to represent or assign a value, imagine height is a variable here, the value of height, that is 5, for example 5 feet, let us say 5 feet. So height, the value is assigned here is 5. This can be generally we write height is equals to 5 centimeters. This is a statement what we going to write. And in the same way here is equals to is used most of the programming languages as assigning of assignment symbol, because assigning means something you are going to represent about that. For example, what is your weight? If the question is given like what is your weight, so here weight is variable, so called as it varies according to the person, and based on the person to person the value will change. And now moving to the next thing, that is when you write this plus operations. So mathematical operations we know that, so whenever you write mathematical operations here, a plus b, here addition, subtraction, you can take two variables a minus b. When you talk about multiplication, we're going to use the star mark, because the normal multiplication symbol cannot be used in the keyboard, so we're going to use multiplication as star here. Division as a slash, a by b, here a by b we have to assume. Power, you can use this symbol cap, a power 3, okay, or a cube we call it as. And reminder, generally whatever that you get after doing the division here, a percentage b, a percentage b. Now so these are the 6 important operations which we going to come across in the flow charts while writing a problem solution for a particular problem. Next, relational operators. Relation means how one is related with other, that is relations, linking of the variable, one variable with the other variable. For example, less than, I think whenever you see a less than b, imagine there are two defined variables, a less than b means a is smaller than b, and or you can say b is more than a, and less than or equals to, we have to write like this. For example, while writing in the notes or whenever you use a handwriting, we are going to write it in different way, but when you talk about using this in this particular flow chart, we have to represent like this: a less than or equals to b. Next, equal to, you see equal to, a is equals to b, so it is normal here, and sometimes we use double equals to in order to relate a and b. Next, a is not equals to b, so generally while writing we just cross the is equals to, but you can use this hash here. A is not equals to b, this is hash symbol here, so a is not equals to b, or we also use this exclamatory mark and is equals to in order to say that a is not equals to b. Now greater than, I think is very much common, and greater than or equals to, as usual we're having two symbols, greater than and equals to. Next, logical operators. So I have been explaining about these operators here: mathematical operators, relational operators. Now it is logical operators. So logical means, for example, when you want to combine two conditions or two relations, we can write like this. For example, you can tell in a simple way, I am younger than my brother, my brother, and my sister is elder than me. My sister is elder than me. So, and I can say, I want to say about two different relations and I want to add them because they are having some reason or logic behind them. For example, you take three brothers you want to represent about their ages, how whether they are elder or younger. Let us say you take a, b, c here. When a is less than b and b is less than c, it means who is the least, or you can say who is the youngest brother of this particular three members. So b is going to be the youngest man and a is going to be the eldest man, but we cannot confirm. Reason is here only two conditions are given. So likewise you may require one more condition in order to say that whether who is what, right? Then or means, when you say about or, whether this or that. So in first case, and means both the things are taken into consideration. Or means the logically you can take either this or that. Let us say a less than b or b less than c. So whenever you try to define about this problem solution, you're going to like this. Next, not means a is not, that means this is what you can say no. When you say no relation or there is nothing called relation between these two, else, that is, if that is not true, if not is acceptable, then that will be true. Okay, then moving to selection control statements. So I think selection control statements, we have to see this. First of all, if, we call it as if condition. So if x greater than 10, so we can say if means whenever that is true, then only this is possible, y is equals to y plus 5. So if first condition is not true, let us say if x greater than 10 is not true, then you cannot write this y is equals to y plus 5. Next, if condition actually makes x greater than 10 is true, execute the statement between then and end if. Okay, between if and then and end if. So here, what is the statement here? Y is equals to y plus 5 is statement. Whenever x greater than 10, we can execute the statement called y is equals to y plus 5. That is called as end if. Next, moving if then. Okay, if then. So what we call if x greater than 10, and then what we can say y is equals to y plus 5. Else, so there are two conditions here. So in the previous example, so where if x greater than 10, then y is equals to y plus 5. Else, end if, that means it is closed, so there is no other alternative. If it is greater than 10 only, we are going to write y is equals to y plus 5. But in the second condition, if x greater than 10, we are going to have y is equals to y plus 5. Else, what is that? We got one more alternative called y is equals to y plus 8 and z is equals to z plus 3. So here two possibilities. If first condition is true, then we are going to have a statement. If not, also we got one more option, that is here we got two options here. here in the form of y is equals to y plus 8 and z is equals to z plus s. Then end if means that it close the condition. So likewise we are going to write about selection control statements. Now loop control statements. Loop means when it comes to writing something within that particular region, we are going to have repetition here. Loop. So while condition. So while and do while, we got this. So while x less than 10, while x less than 10, then do the operation. What is that operation we should do? Print x. That means output we are putting x is equals to x plus 1. So go on adding, x becomes x plus 1. So that we are going to have end do. So do option, do while is closed. Next do, one more is do, only thing is do. So what is that here? Here in the first example, this is called as while do condition, and here it is do condition. So in case of do condition, only operation is taken. That means do print x is equals to x plus 1 until what we are putting here, x greater than 10. If let us say if x greater than 10 means it is infinite. So you know that the value, that is number, may be increased to 10, 11, 12 up to infinite number. So in case if the value is less than 10, that means it may be 1, 2, 3, 5, 6, 7, 8 up to 9. So then you cannot execute this condition. So likewise we are going to have these loop control statements. So just let me revise one more thing. What are the operators we are using? We are going to use in the flowcharts. Mainly we got mathematical operators like arithmetic operations. Along with that we got extra power and reminder here, and then relational operators. The relational operators are about what? Just relating between the two defined variables. Likewise less than or equals to, we got not equals to. And even though relationships are known to us, but the symbols what we use are different in case of writing the flowchart. And logical operators, we got logical operators which are going to combine the two different things or maybe similar activities or operations, so that these called as logical connectors or logical operators. Next, selection control statements. When you talk about selection control statements, whenever you want to do numerous operations, so what we're going to write is we're going to use these selection control statements with the help of if and if else. Okay, if and if else. So if case of if condition, we're going to have two things where there may be chances of ending with one specific statement, or other thing is with the help of writing else also. Means if first thing is not true, then also we got two more alternatives. Likewise it may be two or three more alternatives can be written, and end if shows that that particular condition is closed. We have to say end if means it is closed. Then loop control statements. So loop control statements, we got while loop, do while loop. Okay, we have to understand these two here. And again this also depends on the conditions what we are mentioning here. Based on that we are going to do. End do means again the do condition, do while is closed. Right, so these are the various statements, control statements that are going to be used in writing flowcharts. So let us just go back what we have discussed today. So regarding these flowcharts, we have discussed about the meaning of flowchart, the advantage of writing flowcharts. At the same time we have seen the various what you call the symbols we are going to use while writing the flowcharts, and the meaning as well as the major function of each box is mentioned here. And along with that we have mentioned about the various mathematical operators like mathematical operators, relational operators, logical operators, and selection control statements as well as loop control statements. Even these are also very useful at the time of writing the programs like objective oriented programming language, C language, even in Java we're going to use it. Right, so let us just continue the concepts in the next class. And